Okay, so good morning. We're going to continue with problems, solving problems because you get a much better understanding of what's going on by solving problems. So let's look at this first problem that we have. It says a truck hauls a car cross country, and these are practical situations. So you know and you've seen these things every day, so you can apply physics to the problem and solve the problem. So a truck hauls a car cross country. The truck's mass is 4 times 10 to the power 3 kilograms, and the car mass is 1.6 times 10 to the power 3 kilograms. Okay, so what you have is a situation where you have a towing. So you have a towing. So this is your truck. There's a connection here, a cable, and then you have the car at the back. You have the weight of the truck, the weight of the car, and the tow. It's called the tow truck. The tow truck is pulling the car. Um, if the force of propulsion resulting from the truck's turning wheels is 2.5 times 10 to the power 4 newtons. So that is the force of propulsion from the tow truck. Then the question asks, then determine the acceleration of the car or the truck and the force at which the truck pulls upon the car, assuming irresistant force is negligible. So, so you understand the problem. And when you get questions like this, to eliminate ambiguity, they will either draw the situation or they will um, give you the free body diagram. So we don't have a free body diagram here, but we know that. So we can attempt to draw one. So let's draw a free body diagram because that's the first thing you have to do. So so let's and we're going to do a system approach. First of all, the first thing you need to do is combine. So let's combine them. If we just assume that this is one system, then we can find the acceleration, and that's probably the easiest approach. So remember, you're only going to get acceleration when you get a net force. You only get acceleration when you have a net force. So if we look at the system and let's draw it. So we have the car and then the truck. Okay. So we have one system. We know that the force going forward, if you want to call it the applied force, we know the applied force is 2.5 10 to the times 10 to the power 4 newtons. So the applied force is 2.5 times 10 to the power 4 newtons. Okay. They told us to ignore negligible air resistance. So they want us to ignore the the air resistance and frictional force. So this is going to be your net force. Okay. So this is going to be your net force because they want us to ignore uh, air resistance and friction. In normal life, you can't ignore it. So they will give you a frictional force, air resistance, and it's going to be acting in the opposite direction. If they gave you air resistance, frictional force is going to act in the opposite direction. So you would have to subtract the force going to the left from the force going to the right. to get the net force. So this net force, as we've been talking about, the net force is equal to the mass times acceleration. So we're going to use the mass of the system. Okay? We're going to use the mass of the system. We're going to have the mass of the small car to the mass of the truck. Okay? So you're going to have the mass of the car and the truck together. Just because whatever acceleration, whatever speed that the truck is traveling, the car is going to be traveling the same speed, same acceleration because it is attached. So this net force is equal to the mass of the system, which is the small truck plus the tow truck, because they're in contact with each other. So that would be 5.6 times 10 to the power 3 kilograms. So 5.6, okay, times 10 to the power 3. Okay, so that would be, that's the mass, and the mass is in kilograms. So let's put that as mass. So, and we know that the net force is 2.5 times 10 to the power 4. So if you're going to solve for the acceleration is equal to the net force, which is 2.5 times 10 to the power 4 divided by 5.6 that's 5.6 times 10 to the power 3. And that is your acceleration. So this would be, so 10 to the power 3 into 10 to the power 4 going to give you 10, and then so it will be 22.5, sorry, 25. It will be 25 divided by 5.6. So 25 divided by 5.6. And 25 divided by 5.6 is, all right, so let's do that. All right. Just give me a second to. All right, so that's going to be 4 point something. Let's get it more accurate than that. So it's 25 divided by 5.6 is equal to 4.5. So the acceleration is 4.5. So it's important to realize that you have to treat this as a system, because both the car and the truck is going to have the same acceleration. Okay? So both the car and the truck going to have the same acceleration. Okay? But now the second part of the question asks, and the force at which the truck pulls on the car. So so you have to, in this situation now, you have to separate out the car from the truck. Okay? So let's look at that. So if we have the truck is here. So you have to draw the free body diagram again. We know that the applied force on the truck is 2.5 times 10 to the power 4. So we know that. Pulling, so the truck is pulling the car, and the car is going to pull back on the truck. And it's going to equal to the tension in this cable. Okay? So the truck is pulling forward. Okay? Truck is pulling forward with the disproportion force, and then the tension in the cable, which the car is going to pull back on the truck. Okay, so this is if you want to call this force of tension, then, which is the same thing as the force at which the truck pulls on the car, because the truck is going to pull on the car, and the car is going to pull back on the truck, creating a tension here. So the force at which the truck is pulling on the car and the car pulling back on the truck is the same, the tension. Okay? So let's call that Ft for force of tension. And then this would be the applied force. Okay? So if you separate out the tow truck, you have an applied force pulling it forward, and then the tension due to this little car, due to the car pulling on the cable, which is going to be in the opposite direction. Okay? So we know that net force causes acceleration. So it is this net force which is going to give rise to the acceleration. This net force is the applied force because the car is moving to the right. I mean, the truck is moving to the right. So the net force is the applied force minus the tension, or the if you want to call it contact force, the contact force between the tow truck and the car. So the difference is the net force. Okay, so the net force net, that's equal to the applied force, which is 2.5 times 10 to the power 4 minus the tension force, or if you want to call it the contact force, same thing. Okay, so the net force for the big truck is the propulsion force minus the tension that this little car is pulling backwards on this cable. Okay, that's the net force. And that this net force is going to give rise to the acceleration of the big truck. And that net force is equal to the mass of the big truck, which is 4 times 10 to the power 3 times the acceleration. And we calculate the acceleration to be 4.6. Okay? So the net force is equal to the propulsion force minus the tension force. But the net force is equal to the mass times the acceleration. So these two equations are equal. So you just solve for the tension force. So if you so we have 2.5 times 10 to the power 4 minus the force of tension minus the force of tension. That's equal to 4 times 10 to the power 3 times 4.6. So what you do in that situation now, you just solve for force of tension, which is the force on which the truck pulls up on the car. Okay? So, all right. So if you carry this to the right and you take that to the left, so you'll get the force of tension. Okay, so you're taking that over there. So it's going to be 2.5 times 10 to the power 4. And you're going to subtract from that 4 times 10 to the power 3 times 4.6. So let's see uh, if we can solve that. So, all right. So 4 times 4.6, that is equal to 18.4. So that's 18.4 times 10 to the power. So that's 18.4 times 10 to the power 3. All right. So if you can simplify this multiple ways. You can convert this into 10 into a number times 10 to the power 4. So you'll get 2.5 sorry 2.5 minus, so if you convert this to a power of 10, it will be 1.84. And then outside you would have 10 to the power 4. Okay. So 2.5 minus 1.8 is 0.7. So it will be 0.7. So that is the force, the tension force. The tension force will be 0.7 times 10 to the power 4. Or 7 10 to the power 3, which is the same thing as 7 times 10 to the power 3. So that's the tension in this cable. Okay? So the big truck is pulling, or if you want to say the tow truck is pulling the car. Okay? There's a tension in this cable, and the tension in the cable is 7 times 10 to the power 3. Okay? The first thing you have to do is to look at looking at it as a system. Remember, the truck is moving at a certain speed and accelerating and it's going to have the same acceleration as a little car. It's going to have the same speed because they're attached to each other. So you just solve for acceleration, which is going to be the same for both. So if you solve for acceleration, you can work out anything else. Okay? You want to find out the tension that this the tow truck is pulling. So the forward force propulsion, we know that. We don't know the tension force, which is going in the opposite direction. But the net force, which is the propulsion or applied force minus the tension, is equal to mass times acceleration. Mass of the big car times the acceleration. Okay? And then you can solve for the tension. All right. So once you understand the principle of what you're doing, then it will become straightforward. So the first thing you have to do is do your free body diagram. Okay. All right. So this is another problem taken into consideration. The same type of problem, but let's read. So no, let's do this one first. Okay. So a 7 kilogram box is attached to a 3 kilogram box. So 7 kilogram box attached to a 3 kilogram box. Okay. The 7 kilogram box is pulled by a rope. So this is pulled by a rope with a 25 Newton. So it's pulled by a rope with a force of 25 Newton. Determine the acceleration of the boxes and the tension in this rope. The coefficient of friction between the ground and the boxes is 0.12. So again, if you approach it from a systemic principle, then the forward force, okay, the 7 kilogram box is pulled by a force which is 25 newtons, and that force is to the right. Okay, the forces to the left is gonna be, because it's a system, you're just taking the system. The forces to the left is gonna be the friction. The friction. So the friction force is gonna be the force to the left if you're taking the system into consideration. All right. So let's right. So we have been neglecting the force of gravity and the normal force. We have been neglecting those because those are balanced force. They balance each other out. So we just need the unbalanced force or the net force. That is why we just stick to the forces horizontal. All right. So this forward force, which is your net force. So your net force we're going to force net, okay, is the forward force minus the friction, which is going in the opposite direction. So the forward force is 25, and the force acting to the left is the force of friction, right? Okay, you know that the force of friction the force of friction is equal to the coefficient of friction, mu, times the normal force. So you have to remember that. The normal force of the system is the mass. So the force of gravity would be the mass times the acceleration due to gravity. So if you combine them, the mass is 3 plus 7, that's 10. Okay, times, let's use 10 as let's use 10 for simplicity as the acceleration due to gravity. And we know mu is 0.12. So it will be 0.12, because the normal force is the same as the force due to gravity. So it will be 0.12. Force due to gravity is the mass, which is 10, 7 plus 3. That's the mass, and the acceleration due to gravity, let's use 10 for simplicity, but it's 9.8. So this frictional force is, it's 100 times 0.12, which is 12. Okay, so the frictional force is 12 newtons. So your net force is 25 minus 12, which is 13. So the net force is 13. Remember, the net force is what's going to give you acceleration. So the acceleration of the system, we know that net force, so from Newton's second law, net force is equal to the mass times acceleration. The mass is 10, the acceleration we don't know. That's what we're calculating. Okay, so this is equal to 13. So your acceleration, so that's equal to 13. So your acceleration would be 13 divided by 10, which is 1.3. Acceleration is 1.3. And that's meters per second squared. Okay? So we know the acceleration, right? Now you want to find the tension in this rope because this big box is pulling on this small box with a rope. So there's going to be a tension. Okay? So the force that this big box is going to, remember, this force is pulling the box this way. Tension is going to pull, the tension in this rope is going to pull it in the opposite direction. So the forward force, 25, is going to be pulling the big box, but the tension in this rope is going to pull the box in the opposite direction. So the tension is going to be opposite to the force. Okay? So the force is going in this direction is going to be the tension in the rope plus the friction caused by the big box. So there are two forces going to the left. All right, so you have to draw the situation. You have one force, 25 Newton, pulling to the right, and then two forces pulling to the left. The tension in the rope and the frictional force. Okay? The tension in the rope we don't know, but what we know is that the net force on this 7 kilogram box is this 25, which is the force going to the right, 25, minus the force going to the left, which is the tension. So we know that so so it's the force of tension. Let's call that Ft. And the frictional force. So those are forces that move going to the left. So this net force, the net force is going to cause the acceleration. So it's the acceleration again from Newton's law is the mass, which in this case is 7 kilogram box, times the acceleration. We already calculate the acceleration, so we know because it's a system. So whatever acceleration the big box is traveling, the same acceleration there. Just think about it. They're attached to each other, so they're going to have the same speed, same acceleration. So we can calculate the frictional force created by this 7 kilogram box. Again, frictional force is equal to the coefficient of friction times the normal force. This big box gonna have a force of gravity of 7 mass times acceleration due to gravity 10, so 70. Okay, the normal force is gonna be the same 70. And if you multiply 70 by the coefficient of friction, which is 0.12, then you will get, I think it's 8.4. Okay, so for simplicity, let's take, since we need to find the tension, the tension. They want you to find the tension in rope 1. Let's take tension in rope 1 over to the right, so it becomes positive. So the force of tension, if you take it to the right, so we're going to take this to the right, and then we're going to move this to the left. So this will be 25 so it's 25 minus, so 25 minus the frictional force. So we're going to take this over there, minus the mass times acceleration. Okay, so we say that the frictional force is 0.12 times 70, which gives you, I think it's 8.4. So that's 25 minus 8.4. And you're going to minus the mass of the box times the acceleration. So that is 7 times 1.3. 7 times 1.3 is 7 times 1.3, and that's equal to 9.1. Okay, so this is supposed to be 8.4, right? And then you're going to subtract 9.1. Okay. Tell you what, just give me 1 second. So the tension is equal to 25. So 25 is the force going to the right. And if you're going to subtract from that the frictional force, which is 0.12 times the normal force, which is 8.4, and you're going to the tension in the rope is going that way. So you're going to we already take that to the other side, and then we're going to subtract the mass times the acceleration. The mass is 7, acceleration is 1.3, so that's 9.1. So that gives us a tensional force of, that's 17.5 from 25. So we have 25 minus 17.5, and that is equal to 7.5. So the tension in the rope is 7.5 newtons. Okay. So the tension in the rope. So when you do these problems, you know, if you're in the towing business or you're in some other business that do, you know, these things, you can sit down and work out, you know, and since I'm going to do this towing or whatever, or I'm going to pull this, I need to have a rope that can withstand, you know, this amount of which have, you know, this amount of tension. It can withstand this tension. You know, so you don't want to use a rope that can't withstand this amount of tension. It's going to snap. So these things have practical implications. So it's not just sitting down and working out problem for working out problem sake. But if you're in a business that, you know, do these things, you have to do your homework, because if you don't, you're going to run into problems. You know, so as you see, the important thing is to know the forces acting on the object. Draw the forces acting on the object. Remember that net force is going to give rise to acceleration. So you have to vector sum the forces, and then you have to know that that net force is going to cause the acceleration. Remember from Newton's second law, the net force is equal to the mass times the acceleration. Once you get the acceleration, then you can work out contact force and tension. All right. Let us stop here.